Hi everybody, this is Mrs. Lindsay Pereira. Today we are starting section 2-3, but before we get into that we do have a little bit of a warm-up. So either if you're working individually with a partner or in a group, I would like you to pause this video and then go through A through M and fill in true or false, okay, when you're looking at your diagrams. When you're ready, push play and you can check your answers. Okay, so here we have the answers to A through E. All points are collinear. D, G, and I are collinear, and that is not true. Even though they look like it, there needs to be a line drawn on there because those are 3 points. A, C, H, true. They all lie on the same line. E, G, and AH perpendicular. Yes, it's marked. And then also we have angle BCA and angle ACD are a linear pair. So again, you can assume straight angles there. So yes, they're adjacent and supplementary. Going to the next ones, the next two, not enough information to tell. Again, the only reason we can say that we have a perpendicular is because it's marked on the diagram. That's not something you can assume. So F and G are going to be false because we know nothing else about the diagram. Again, all the points are coplanar, all the lines are coplanar. EG and BD do not, excuse me, intersect. And actually, that should be true. They do not intersect. EG is here, and then we have BD here, and they don't intersect. Okay. AF and BD do intersect, true. EG and BD are perpendicular, and that is false. Then we have a set of vertical angles. That is something you can get from straight lines, so yes, that is true. And AC and FH are the same line, also true. Okay, so let's actually talk about what section 2-3 is about, postulates and diagrams. Okay, so we have a few different postulates here. I want you to pause the video. Please take a moment and kind of read through these. I don't exactly always refer to these by name, but these are something you need to know. So take a moment, pause the video, and read through these, and then we'll talk about them. Okay, so 2-point postulate. Again, this is kind of how we unofficially define a line. Through any 2 points, there exists exactly one line. And then the line point postulate. A line contains at least 2 points. There's infinitely amount of points on there. Okay. Line intersection postulates. If 2 lines intersect, they intersect at exactly 1 point. The 3-point postulate. 3 non-collinear points form a plane. All right, so any 3 non-collinear points, there exists exactly 1 plane. And a plane contains at least 3 non-collinear points. Okay, kind of the reverse of that. Plane line postulate, if 2 points lie in a plane, then the line containing them lies in the plane. Hopefully that makes sense. Hopefully a lot of these just make sense. And the plane intersection, if 2 planes intersect, again, they go indefinitely in both directions, so their intersection is a line. Okay? So let's go through a few examples here. So here we have 2 planes. We have plane P and plane Q, and we want to know, are they perpendicular? And again, no markings on here. We don't know that, so this would be false. Lines M and N intersect at A, and that is true. Now we want to sketch a diagram showing that ray Vx intersecting line UW at V, so that Vx is perpendicular to line UV, and UV and W are collinear. Okay, there's a lot going on there. Okay, so start over, read it again. We want to sketch a diagram where Vx intersects UW at V. Okay, So again, I'm just going to draw that, and I know I got some perpendicular line in here, so I'm going to kind of draw a line here with U and W, and I know again Vx is going to be perpendicular to it. So Vx is going to be perpendicular, and I know they intersect at V, so I need to put the V here and the W here. Okay. And then I need to make sure that we have the line that U, V, and W are all collinear. Yes. So we're good to go on that. Okay. So sometimes it takes going through, kind of highlighting things. Don't be afraid if you drew it wrong and you have to redo it. That happens. Okay. Just make sure that all those different criteria line up there. Okay. So the line perpendicular to a plane. A line is perpendicular to plane if and only if the line intersects the plane in a point and is perpendicular to every line in the plane that intersects at that point. We typically call B the foot. You might see that in some textbooks. But again, it needs to be perpendicular not only to BD, but it needs to be perpendicular over here to BC. And it's hard to draw this one, but also perpendicular to BE. So anything that goes through that intersection point B, where it's on the plane, it has to be perpendicular. Okay. So let's take a look here. And again, this doesn't look the best. It's difficult to draw some of these sometimes, but let's read it. We have A, B, C, D, and F lie in the vertical plane M. We know that the line PF is perpendicular to M. So again, that's kind of what I would call the foot, right? This point right here, the point that intersects on the plane. So anything that goes through there is going to be perpendicular. So we'd have angles PFA, PFB, and notice F, the foot, the point of intersection with the plane, that's always going to be the vertex, PFC, and angle PFD. All of those would be actually right angles. Okay. All right, so let's move on to our last couple examples here. How many right angles are there? So let's look at the description here. We have ABCD is a square. It lies in the plane T. We also know that PF, line PF is perpendicular to T. I actually want you to pause this. I want you to count up how many right angles you think you see there. Okay? And then push play when you're ready to check your answer. Okay. So the answer is 12. Let's go through them. Let's just start with the square. So we have an angle at each of the corners of the square. Okay. Then if I just look at my square, I'm not looking at anything that's not inside that plane. Each of these angles, this might be what you missed in the middle, are right angles. So within the square, there are 8 right angles. Okay. But then, and I'm going to erase this because that's, again, I'm only looking inside the square, right? So I'm only looking at these angles that intersect of the diagonals of the square, and then these 4 corner angles. So that's where those 8 come from. But now if I look at the line being perpendicular to plane T, now I have angle PFD, PFC. Again, this is hard to draw a little bit so that you can see all those PFB and PFA. So from there I get 4. That's why we had a total of 12. Okay. And our last example. Which of the following statements cannot be assumed? Okay. And again, I want you to actually push pause on this and circle the ones that cannot be assumed. And we have 4 of them here. So we get there exists a plane that contains points A, D, E, and etc. So circle the ones that are not, you cannot assume. Okay, so let's go through this. and 2 is the only one. There exists a plane that contains points A, D, E. Again, any 3 non-collinear points form exactly one plane. It doesn't happen to be drawn in this picture, but it is a true statement. Okay? I'm going to jump down to 3. AB is perpendicular to the plane because of this symbol right here. If that wasn't there, that would not be something we can assume. We can never assume right angles. 4, line AF is in plane T. That is true. And the one that can't be assumed here as well, AB is equal to EF. We don't know anything about congruency on any of this, so that is the only one that cannot be assumed. Okay? And this concludes our notes on section 2-3.